December 16, 1944, the Ardennes forest. Fog clings to frozen earth like a burial shroud. Inside the cramped hull of an M4A1 Sherman, Sergeant Bill Harper watches his loader lift a 76mm round from its rack. The shell looks different, heavier. The tip is painted black with a white band, a marking Harper has never seen before. His fingers are numb despite his gloves. Outside, the forest is silent except for the distant rumble of engines. "German engines, HVAP," the loader mutters, reading stenciled letters on the casing. "High-velocity armor piercing. Just came up yesterday." Harper has heard the rumors. A new round. Something that might actually punch through a Panther's frontal plate. But rumors don't stop an 80mm shell. Rumors don't bring dead crews back. Through his periscope. Movement. 600 yards out, emerging from the tree line like iron ghosts, two Panther OSFG tanks, their long-barreled 75mm guns traversing slowly. Hunting. Harper's throat tightens. Every instinct tells him to reverse, to find cover, to avoid this fight. For 18 months, American tank crews have learned a brutal lesson. You don't face a Panther head-on. You flank it. You call in air support. You pray. But the supply sergeant's words echo in his memory. This round will change everything. The loader slams the breech shut. The black-tipped shell sits in the chamber. Harper steadies his breath and places his eye against the gun sight. His hand hovers over the firing lever. The Panther's glacis plate fills his view. 60 millimeters of sloped German steel that has turned away. Every American shell for the past 6 months. Everything he knows about armored warfare says this is suicide. Everything about this new round says otherwise. The question is, who's right? By the summer of 1944, American armor doctrine faced a crisis it could no longer ignore. The Sherman tank, backbone of the Allied armored forces, had carried the United States through North Africa, Sicily, and into the hedgerows of Normandy, with reliable performance and mechanical endurance. But reliability meant nothing when your main gun couldn't penetrate the enemy. The standard M4 Sherman mounted a 75mm M3 gun, a weapon adequate against German Panzer III's and early-model Panzer-Bifors. Against the newest generation of German armor, it was catastrophically inadequate. The Panther tank, introduced by Germany in 1943, represented a technological leap that American planners had not anticipated. Its frontal glacis plate measured 80 millimeters thick, sloped at 55 degrees, a geometric arrangement that effectively doubled its protective value. American tankers discovered this reality in the most visceral way possible, by watching their 75mm armor-piercing shells bounce off Panther hulls like stones skipping on water. Even at close range, 300 yards or less, the standard M61 armor-piercing shot could not reliably defeat Panther frontal armor. Crews reported the sickening sound of their rounds ricocheting away, while German return fire turned their Shermans into crematoriums. The casualty reports from Normandy told a grim story. In engagements between Shermans and Panthers, American losses ran 4-1 or worse. Tank crews began refusing to advance when German heavy armor was reported ahead. Morale collapsed. Men calculated their odds of survival in weeks, not months. The U.S. Army Ordnance Department had seen this coming. As early as 1942, development began on an upgraded Sherman mounting a 76mm M1 gun. Weapon with higher muzzle, velocity and better armor-piercing capability than the 70mm or T-45mm. The first 76mm armed Shermans reached Europe in July 1944, arriving with the buildup of forces after D-Day. Crews greeted them with cautious hope. Perhaps this longer gun would level the battlefield. It didn't. The 76mm gun fired the M62 armor-piercing capped ballistic cap round at 2,600 feet per second. a respectable velocity. Against the Panther's side armor or the Tiger's frontal plate at close range, it could achieve penetration. But against a Panther's glacis at combat ranges beyond 500 yards, the M62 round still failed more often than it succeeded. The problem was fundamental physics. The M62 projectile, though faster than the 75mm round, still relied on a solid steel penetrator. At impact, the steel deformed and shattered against the Panther's hardened armor face. Penetration required not just velocity, but also material hardness that exceeded the target. Tank commanders found themselves in an impossible tactical bind. To kill a Panther frontally with a 76mm Sherman, you needed to close to suicidal ranges under 400 yards, where the Panther's own 75mm KWK-42 gun could effortlessly destroy you first. That German gun fired at 3,068 feet per second and could penetrate a Sherman's frontal armor at over a mile. The mathematics of mutual engagement favored the Panther so overwhelmingly that American doctrine evolved around avoidance. Find the flanks. Use superior numbers. Accept the losses. But flanking maneuvers cost time, fuel, and lives. In the close terrain of French hedgerows and later the Ardennes forests, flanking opportunities were rare. German tank commanders positioned their Panthers in hull-down defensive positions, glacis plates angled toward likely American approach routes, and waited. They knew the Americans had no answer. By autumn 1944, the strategic situation demanded a solution. Allied forces were pushing toward the Rhine, and every day brought more encounters with German armor. The Wehrmacht was deploying Panthers in greater numbers. Over 6,000 would be produced in 1944 alone. American tank production dwarfed German output, but sheer numbers meant nothing when 4 Shermans died to kill 1 Panther. The answer lay not in a new tank, but in a new bullet. Tungsten carbide, a material 6 times harder than steel and nearly as dense, had been used in industrial cutting tools for decades. American ordnance engineers recognized its potential for armor penetration as early as 1943. A projectile core made of tungsten. Carbide could maintain structural integrity at impact, velocities that would shatter steel. It wouldn't deform. It wouldn't mushroom. It would punch through hardened armor like a nail through wood. The concept was called HVAP, high-velocity armor piercing. The British called their version APDS, armor-piercing discarding sabot. The principle was identical. A dense, hard, sub-caliber core wrapped in a lightweight aluminum body that fell away after leaving the barrel, allowing the core to fly at extreme velocity with minimal air resistance. For the 76mm gun, the T4 HVAP round was designed with a tungsten carbide core just 45 millimeters in diameter, centered inside an aluminum sabot that brought the round to full 76mm caliber. When fired, the lightweight package achieved a muzzle velocity of 3,400 feet per second, 800 feet per second faster than standard ammunition. At impact, the sabot petals peeled away, and the tungsten core struck its target with devastating kinetic energy, focused on a tiny contact point. In testing at Ardennes Proving Ground in Maryland, the results were extraordinary. At 500 yards, the T4 HVAP penetrated 150 millimeters of vertical armor plate. Against sloped armor equivalent to the Panther's glacis, it could achieve penetration at ranges exceeding 1,000 yards, double the effective range of standard ammunition. The Pentagon authorized production in mid-1944, designating the round as M93 HVAP. But there was a problem. Tungsten was scarce. American industry needed tungsten for machine tools, cutting equipment, and a dozen other war production applications. The entire national stockpile had to be carefully rationed. HVAP rounds would be produced in limited quantities and distributed only to frontline units facing heavy German armor. The first shipments reached Europe in October 1944. 5 rounds per tank, sometimes 10 if you were lucky. Crews were instructed to use them only against panthers, tigers, and other heavy targets. Every round was accounted for. Every expenditure required justification. The men who loaded those black-tipped shells into their guns had no illusions. This wasn't a miracle. It was a chance. A narrow, expensive chance to fight back against an enemy that had dominated them for too long. The Panther tank did not earn its fearsome reputation through propaganda. It earned it through engineering. When Germany invaded the Soviet Union in June 1941, Wehrmacht armored forces encountered the T-34, a Soviet medium tank that shocked German commanders with its combination of sloped armor, mobility, and firepower. The T-34's 45mm frontal armor, angled at 60 degrees, proved nearly impervious to standard German anti-tank guns. Its 76.2mm main gun could destroy any German tank then in service. The psychological impact on German crews was profound. For the first time, they faced an opponent they could not reliably kill. German response was swift and ambitious. In November 1941, Daimler-Benz and Mayenne received contracts to develop a new medium tank incorporating the lessons learned from the T-34. The result, designated Panzerkampfwagen V-Panther, entered production in late 1942. It was not merely an improvement over existing designs. It was a generational leap. The Panther's glacis plate measured 80 millimeters at 55 degrees from vertical. Configuration that provided effective protection equivalent to 140 millimeters of flat armor. Its Maybach HL-230 engine delivered 700 horsepower, propelling the 45-ton vehicle to speeds of 30 miles per hour on roads. The main armament, the 75mm KBK 42L70 gun, possessed a barrel length of 5.25 meters and fired armor-piercing rounds at velocities approaching 3,100 feet per second. At 1,000 yards, it could penetrate 120 millimeters of armor. At 2,000 yards, it remained lethal against any Allied tank. German tank crews called it the finest tank of the war. Allied intelligence called it a nightmare. By mid-1944, Panthers equipped entire panzer divisions on the Western Front. They fought from defensive positions in Normandy, where their superior range and armor allowed single tanks to hold off entire American columns. At the Battle of Ardennes in September 1944, German Panthers engaged American Shermans across open terrain, destroying dozens before withdrawing with minimal losses. At Aachen in October, Panthers positioned in rubble and ruins turned urban, streets into killing zones where American armor could not advance without prohibitive casualties. The effect on American tank crews was measured, not in statistics but in behavior. Veterans developed what psychiatrists would later recognize as combat trauma, specifically associated with facing German heavy armor. Men refused to button up their hatches, preferring the risk of small arms fire to being trapped inside a burning hull. Crews bailed out at the first sign of Panther silhouettes, abandoning serviceable tanks rather than engaging. Replacement crews arrived in Europe with life expectancy estimates of 6 weeks. Lieutenant Belton Cooper, an ordnance officer with the 3rd Armored Division, documented the carnage in his post-war memoir. He described fields littered with burned-out Shermans, their turrets blown off by catastrophic ammunition fires. He recounted crews pulled from wrecked tanks with injuries so severe that identification required dental records. The Sherman's gasoline engine and vertically stored ammunition created what tankers grimly called a Ronson, a reference to the cigarette lighter company's slogan. Lights first time, every time. American armor doctrine adapted through necessity. Tank destroyers, lightly armored vehicles mounting high-velocity guns, were supposed to handle enemy armor while Shermans provided infantry support. But tank destroyers like the M10 and M18 carried open-topped turrets that made them vulnerable to artillery and infantry, and their thin armor offered no protection in direct engagements. The M36 tank destroyer, armed with a 90mm gun, showed promise, but arrived in limited numbers too late to affect the Normandy campaign. The strategic calculus was brutal. America could produce Shermans faster than Germany could produce Panthers. 5 Shermans for every Panther built. If trading 5 tanks for one was acceptable, the war could be won through attrition. But the men inside those 5 tanks did not find this acceptable. Neither did their families. Neither did the generals who watched their armored spearheads stall whenever German heavy tanks appeared. The push for HVAP ammunition came from multiple directions simultaneously. Field commanders sent urgent requests through channels. Ordnance officers compiled after-action reports demonstrating the 76mm gun's inadequacy. Metallurgists and ballisticians worked around the clock at Ardennes Proving Ground, testing tungsten alloys and sabot designs. The project received priority classification in August 1944, with President Roosevelt personally authorizing increased tungsten allocation for ammunition production. But tungsten remained the bottleneck. The United States imported most of its tungsten from China, Bolivia, and Portugal, supply lines vulnerable to submarine warfare and political instability. Domestic tungsten mines in Colorado and California operated at maximum capacity but could not meet total demand. Every HVAP round required approximately 40 grams of tungsten carbide. A single Sherman carried 71 rounds of 76mm ammunition. If every round were HVAP, one tank would consume nearly 3 kilograms of tungsten, enough material to produce cutting tools for 10 machine shops. Production priorities forced compromise. The War Production Board allocated tungsten to HVAP manufacturing on a quota system. In October 1944, American factories produced 30,093 HVAP rounds. In November, 50,000. In December, as the Battle of the Bulge erupted, production surged to 80,000 rounds per month. But with thousands of 76mm Shermans in Europe, distribution averaged just 10 rounds per tank per month. Field commanders received explicit instructions. HVAP was not general-purpose ammunition. Use it only against heavy armor. Conserve it. Account for every round expended. Crews who wasted HVAP on targets that standard ammunition could handle faced disciplinary action. The psychological impact of scarcity was significant. Crews hoarded their HVAP rounds like gold, reluctant to expend them even in situations where they might prove decisive. Some tanks entered combat with HVAP rounds still racked, their crews saving them for a worse situation that never arrived. Others fired all their HVAP in the first engagement, then faced subsequent battles with only standard ammunition. Training on HVAP characteristics was minimal. Most crews received a single briefing. The rounds have black tips, they fly faster, they penetrate better. Fire them at panthers and tigers. That was the extent of instruction. Nobody explained the ballistic differences, that HVAP trajectories dropped less at range, that windage corrections differed, that the tungsten core required precise shot placement to maximize effectiveness. Some crews never received HVAP at all. Supply chains prioritized frontline units in direct contact with German armor. Rear echelon tanks, reserve formations, and units in quiet sectors went without. The distribution was uneven, chaotic, and often dependent on personal relationships between supply sergeants and combat commanders. By December 1944, HVAP had been in the field for 2 months. Some crews swore by it, claiming confirmed Panther kills at ranges previously unthinkable. Others remained skeptical, having fired HVAP rounds that failed to penetrate or missed entirely due to unfamiliarity with the round's flight characteristics. After-action reports were inconsistent, often filed by exhausted men who could not accurately reconstruct high-speed engagements conducted through periscopes in smoke and chaos. What was undeniable was this. For the first time since Normandy, American tank crews possessed a weapon that could kill a Panther from the front at combat ranges. Whether they would live long enough to use it effectively was another question entirely. The Germans, for their part, had no idea what was coming. Their intelligence services tracked Allied tank production, monitored Sherman variants, and analyzed captured vehicles. They knew about the 76mm gun. They knew its standard ammunition could not reliably defeat Panther armor at normal engagement distances. Their tactical doctrine reflected this knowledge. Panthers engaged American armor frontally with confidence, their crews trained to exploit their invulnerability. No German intelligence report from late 1944 mentioned HVAP. No captured document referenced tungsten core ammunition. The Wehrmacht entered the winter of 1944 believing the armored balance remained decisively in their favor. That belief would not survive contact with the black-tipped rounds, the difference between failure and success in armor. Penetration is measured in fractions of a second and microscopic material properties. When a standard M62 armor-piercing round struck a Panther's glacis plate, the impact occurred at approximately 2,400 feet per second, after traveling 500 yards. The steel penetrator, hardened to Rockwell C-scale 4852, met German face-hardened armor at Rockwell C60-64. In that microsecond of contact, the American projectile, softer than its target, began to deform. The tip mushroomed, the body compressed, energy dissipated laterally rather than driving forward. If the impact angle was poor, the round deflected entirely, careening away in a shower of sparks. If the angle was favorable, the round might create a shallow crater before shattering. Either way, the crew inside the Panther remained unharmed. HVAP changed the physics entirely. The M93 round's tungsten carbide core possessed a Rockwell, a hardness of 92, harder than any steel armor Germany could produce. When it struck at 3,200 feet per second, its velocity after 500 yards, the core did not deform. It did not mushroom. The tungsten maintained its shape and drove forward with kinetic energy concentrated on a contact area of just 16 square millimeters. The armor, not the projectile, failed. The tungsten carved through the Panther's glacis like a punch press through sheet metal, creating a cylindrical hole that allowed the core to penetrate into the fighting compartment. But velocity alone did not explain HVAP's effectiveness. The sabot design was equally critical. A full-caliber 76mm projectile, weighing 15 pounds, faced significant air resistance in flight. Drag reduced velocity rapidly. The M62 lost nearly 200 feet per second for every 500 yards traveled. The HVAP's tungsten core weighed just 4 pounds. Wrapped in its lightweight aluminum sabot, the complete round weighed only 9 pounds. After leaving the muzzle, the sabot petals separated and fell away within 30 feet, leaving only the dense core to continue downrange. With its tiny cross-section and heavy mass, the tungsten core maintained velocity far better than conventional ammunition. At 1,000 yards, HVAP retained 2,800 feet per second, still faster than standard ammunition at the muzzle. This had tactical implications crews discovered through trial and error. HVAP's flatter trajectory meant less holdover at range. A gunner aiming at a Panther at 800 yards needed only half the elevation correction compared to standard ammunition. In the frantic seconds of tank combat, this simplified ballistic solution translated directly into faster target engagement and higher hit probability. The tungsten core's small diameter created another unexpected advantage. Traditional armor-piercing theory held that larger projectiles created more post-penetration damage. A 90mm shell punching through armor would theoretically cause more havoc inside a tank than a 76mm shell. But HVAP inverted this assumption. The narrow tungsten core penetrated cleanly, then tumbled violently after breaching the armor. Its dense mass, suddenly unstable in the confined space of a tank interior, ricocheted at high velocity off internal surfaces, engine blocks, ammunition racks, crew stations. The effect was similar to a high-velocity rifle bullet tumbling through tissue. Multiple impact points, unpredictable trajectory, catastrophic secondary damage. Tankers who witnessed successful HVAP penetrations reported Panthers erupting in secondary explosions moments after impact, not from the initial penetration, but from ammunition fires triggered by the tumbling core. Others described German crews bailing out of apparently undamaged tanks, later investigation revealing that the tungsten core had ricocheted through the fighting compartment multiple times, killing or wounding everyone inside without creating visible external damage beyond the entry hole. Yet HVAP was not without limitations. The tungsten core's small diameter meant it contained less explosive filler than conventional armor-piercing rounds. Some HVAP cores were solid tungsten, with no explosive content whatsoever. Pure kinetic penetrators. Against softer targets like half-tracks, bunkers, or buildings, HVAP was wasteful overkill. Its value existed only against hardened armor at extended range. The scarcity of tungsten also created a strategic vulnerability. If German intelligence identified HVAP and prioritized destroying American tungsten supply lines, the entire ammunition program could collapse. Every shipment from South American mines represented a potential choke point. Every cargo vessel crossing the Atlantic carried material that could not be quickly replaced. American ordnance officers understood this fragility. They mandated strict accountability not just to conserve tungsten for production, but to prevent German intelligence from recognizing the ammunition's significance through battlefield recovery. Orders emphasized that HVAP should be fired only when necessary, and that crews should avoid abandoning tanks containing HVAP rounds where Germans might capture them. Some crews, paranoid about capture, removed HVAP rounds from their ready racks during lulls in combat, storing them in external sponson boxes or even burying them near their defensive positions. This defeated the purpose. Rounds inaccessible during combat might as well not exist, but it reflected the psychological tension between hoarding a precious resource and risking its loss. The ballistic revolution, HVAP represented extended beyond immediate tactical utility. It validated a principle that would dominate Cold War armor development. Kinetic energy penetrators fired at extreme velocity could defeat any practical thickness of steel armor. The race between armor and ammunition had entered a new phase where material science mattered more than caliber size. Bigger guns were not the answer. Smarter bullets were. Inside a Sherman, HVAP arrived not as salvation, but as rumor. Sergeant Mike Colby, a gunner with the 4th Armored Division, first heard about the new ammunition from a supply sergeant in November 1944. "Black-tip rounds," the sergeant said. "They'll punch through a Panther like it's made of cardboard." Colby didn't believe him. He'd heard promises before. The 76mm gun was supposed to solve everything. It hadn't. When the rounds actually arrived, 5 of them stacked carefully in a wooden crate, Colby's crew gathered around like prospectors examining gold. The shells looked heavier somehow, though the weight difference was negligible. The black tip and white band made them unmistakable. The stenciled designation M93 HVAP meant nothing to men who thought in terms of what kills and what doesn't. The loader, a kid from Ohio named Patterson, asked the obvious question: how do we know they work? Nobody had an answer. There were no training ranges in combat zones, no test targets. The first time any crew would know if HVAP worked was when they fired it at a Panther and either survived or didn't. This uncertainty gnawed at crews across the front. Tank combat occurred at ranges where seconds determined survival. A gunner who missed with his first shot often didn't get a second. If HVAP rounds had different ballistic properties, if they dropped more or less than standard ammunition, if windage affected them differently, A gunner's muscle memory and experience became liabilities. The safest approach was to fire a test round to observe the trajectory. But with only 5 or 10 HVAP rounds per tank, nobody could afford to waste one on experimentation. Some crews developed informal testing protocols. They'd fire one HVAP round at a distant tree or abandoned vehicle, observing the impact point relative to where they'd aimed. This provided crude ballistic data, though it cost them 20% of their HVAP allocation. Other crews refused to test fire, reasoning that saving every round maximized their chances in actual combat. The lack of standardized training meant every tank developed its own doctrine. Technical Sergeant Bill Rogers, a tank commander with the 2nd Armored Division, took a different approach. He kept his HVAP rounds in the loader's ready rack, but instructed his gunner to engage every target with standard ammunition first. Only if the first shot failed to penetrate would they switch to HVAP. "We can't afford to waste them on targets we can kill anyway," Rogers explained to his crew, "but we also can't afford to die because we were too stingy to use them." This philosophy created agonizing tactical decisions. When a Panther appeared at 700 yards, a range where standard M62 ammunition might penetrate with a perfect shot to a weak point, did you gamble on the cheaper round or immediately use HVAP? If you used HVAP and killed the Panther, had you wasted a precious resource on a target you might have killed anyway? If you used standard ammunition and failed to penetrate, the Panther's return fire would likely kill you before you could load HVAP. Crews argued about these calculations during every lull in combat. Some commanders adopted aggressive HVAP employment. Fire it first, maximize your survival chances, worry about scarcity later. Others remained conservative, viewing each HVAP round as insurance against a worst-case scenario that might never arrive. The psychological burden was real. Loader Patterson later described the weight of holding an HVAP round during combat. "You're thinking, this might be the one that saves us. But if I load it and we miss, did I just kill us? Should I have waited for a better shot?" Gunners faced parallel pressure. An HVAP round's superior ballistics meant you could engage targets at ranges where standard ammunition was useless. But longer-range shots had lower hit probabilities. Was it better to hold fire with HVAP until the Panther closed to 600 yards, where your hit probability was 80%, or fire at 1,000 yards, where hit probability dropped to 30%, but the Panther couldn't effectively return fire yet? There were no correct answers, only dead crews and surviving crews, and the survivors never knew if their choices had been wise or merely lucky. The Wehrmacht's intelligence apparatus, for all its efficiency in other domains, completely missed the introduction of HVAP ammunition until it was too late to matter. German intelligence collection on Allied armored forces followed established patterns. Reconnaissance units photographed knocked-out American tanks, measuring armor thickness and gun caliber. Interrogators questioned captured tank crews about doctrine, tactics, and equipment. Ordnance specialists examined captured ammunition, cataloging types, and performance characteristics. Reports flowed up through division, corps, and Army Group headquarters to the Waffenamt, the German Army Weapons Agency, which maintained comprehensive technical assessments of enemy capabilities. Throughout 1944, these reports consistently described American tank armament as inferior. Captured M62 armor-piercing rounds were tested against German armor plate at Kummersdorf, proving ground outside Berlin. The results confirmed what Panther crews already knew. The 76mm gun could not reliably penetrate Panther frontal armor beyond close range. Intelligence summaries distributed to Panzer units in October 1944 explicitly stated that American tanks posed minimal threat in frontal engagements. Tactical doctrine emphasized this advantage. Panthers should engage American armor from hull-down positions at maximum range, exploiting their superior gun performance. No German intelligence document from 1944 mentioned tungsten core ammunition. No interrogation report recorded American crews discussing HVAP. No technical analysis identified the black-tipped rounds as representing a qualitative threat. This failure had multiple causes. First, HVAP's late introduction meant few rounds existed in the field. Before December 1944, German forces that overran American positions in the opening days of the Battle of the Bulge captured hundreds of Sherman tanks, but most contained only standard ammunition. The few HVAP rounds that might have been present were visually similar enough to standard AP rounds that hasty battlefield recovery operations overlooked them. Second, American crews followed strict orders to account for HVAP expenditure. Rounds were logged, tracked, and when possible recovered after engagements. Unlike standard ammunition, which was fired freely and abandoned readily, HVAP was treated as controlled material. This reduced German opportunities to capture samples. Third, German intelligence priorities in late 1944 focused elsewhere. The Wehrmacht faced strategic collapse on multiple fronts. Soviet forces were advancing through Poland. Allied armies approached the Rhine. German intelligence resources concentrated on enemy intentions. Where would the next offensive occur? What were Allied force dispositions? What were strategic objectives? Technical analysis of ammunition types ranked low on priority lists, managed by men fighting to prevent national defeat. But the most significant factor was cognitive bias. German armor officers believed in Panther superiority as an article of faith, supported by 18 months of battlefield results. The Americans had tried the 76mm gun, and it had failed. Why would they try something different? German doctrine assumed the Allies would respond to armor inferiority with numerical superiority. More tanks, more air power, more artillery support. The possibility that Americans might develop ammunition capable of defeating Panther armor frontally contradicted established German assumptions about Allied technical capabilities. This dismissiveness had historical roots. Throughout the war, German engineering had maintained qualitative superiority over Allied equipment. German tanks had better guns, better armor, better optics. German small arms, artillery, and aircraft consistently outperformed Allied equivalents in direct comparisons. German engineers believed, correctly, that they possessed more advanced metallurgical knowledge, more sophisticated manufacturing techniques, and more innovative design philosophies. The idea that Americans could develop a breakthrough ammunition using advanced materials never occurred to intelligence analysts who viewed American industry as capable of mass production but incapable of technical sophistication. When HVAP first appeared in combat, German crews attributed their losses to other factors. A Panther knocked out by a frontal hit at long range was assumed to have been struck by a tank destroyer's 90mm gun, or by anti-tank artillery, or by a lucky shot that found a weak point in the armor. After-action reports described engagements with unidentified high-velocity weapons, but did not connect these incidents to a pattern. The first credible German report identifying HVAP came in January 1945, when Ordnance technicians examined a knocked-out Panther near Bastogne. The entry hole in the glacis plate was smaller than typical 76mm damage, barely 75 millimeters in diameter, with clean edges suggesting an extremely hard penetrator. Inside the hull, technicians found tungsten fragments. The report reached Waffenamt with a priority classification. Americans possessed tungsten core ammunition for 76mm guns. By then, it was too late. Production of tungsten carbide penetrators required industrial infrastructure Germany no longer possessed. Allied bombing had destroyed machine tool factories. Tungsten supplies from Portugal had been interdicted. Even if Germany could produce HVAP equivalents, distribution to frontline units would be impossible through shattered supply networks. The intelligence failure extended beyond simple oversight. It represented a fundamental misunderstanding of American strategic philosophy. The Wehrmacht viewed tank design as a zero-sum competition. Better armor, better guns, better engineering. The Americans viewed it as a systems problem. Adequate platforms, superior logistics, and continuous incremental improvements. HVAP embodied this philosophy. Rather than designing a new tank, they developed new ammunition for existing tanks. Rather than pursuing perfect solutions, they accepted good enough solutions delivered in quantity. German military culture, steeped in engineering excellence and technological pride, could not comprehend an approach that prioritized practical results over elegant design. This blindness cost them the armored advantage they believed unassailable. HVAP did not merely provide American tank crews with better ammunition, it fundamentally altered engagement doctrine at every level from individual tanks to armored divisions. Before HVAP, American armor tactics against Panthers followed predictable patterns born from desperate necessity. Tank platoons maneuvered in teams of 5, attempting to fix German armor frontally, while additional tanks flanked from concealment. The lead tank, often called the bait tank, drew fire and died, while others sought firing positions against side or rear armor. It was effective in the sense that it eventually killed Panthers, but the cost in Shermans and crew lives made it a doctrine of attrition rather than maneuver. Engagement ranges dictated everything. American commanders knew their tanks had to close within 400 yards for reliable penetration against Panther frontal armor. German commanders knew this too, which meant they positioned Panthers to control long sight lines where American tanks had to advance across open ground under fire. The tactical geometry favored defense so overwhelmingly that American offensives stalled whenever Panthers appeared in prepared positions. HVAP inverted this geometry. With effective frontal penetration capability out to 1,000 yards, American tanks could now engage Panthers at ranges where German return fire remained dangerous but not insurmountable. A Sherman firing HVAP at 800 yards could kill a Panther before closing to the distance where Panther fire became nearly certain to penetrate. This margin, the zone between 600 and 1,000 yards, became the new optimal engagement range for American armor. Tank commanders adjusted their tactics immediately. Instead of rushing forward to close range, they halted at distance and engaged with HVAP. Instead of seeking flanking routes, they accepted frontal duels. The psychological shift was profound. Crews who had spent months avoiding direct confrontation with Panthers now sought those confrontations, confident in their ammunition's capability. But doctrine evolution was uneven and chaotic. Units that received substantial HVAP allocations, 20 or more rounds per tank, developed aggressive engagement tactics. They advanced with confidence, fired at distant targets, and accepted ammunition expenditure as the cost of reducing casualties. Units that received minimal allocations, 5 rounds per tank, remained conservative, continuing to employ flanking tactics and using HVAP only as a last resort. This disparity created coordination problems at battalion and regimental levels. Attack plans assumed uniform capability across armored formations, but actual capability varied wildly based on HVAP availability. A company with abundant HVAP could punch through German defensive lines that would stop a company without it. Commanders learned to concentrate HVAP-equipped tanks at breakthrough points, using them as armored spearheads, while tanks with standard ammunition provided flank security or engaged softer targets. Artillery coordination also changed. Previously, American doctrine called for heavy artillery preparation before tank advances, attempting to suppress German anti-tank guns and destroy Panthers before Shermans entered engagement range. With HVAP, tanks could advance under lighter artillery support, engaging Panthers directly rather than waiting for indirect fire to neutralize them. This accelerated operational tempo, allowing armored divisions to exploit breakthroughs before German reserves could counterattack. The Germans noticed. After-action reports from panzer divisions in January 1945 described American armor as more aggressive and willing to engage at longer ranges. German tank commanders, accustomed to American tanks withdrawing or maneuvering when Panthers appeared, now faced Shermans that held position and traded fire. The psychological impact was significant. Panther crews had enjoyed 18 months of tactical superiority, and suddenly that superiority vanished. German defensive doctrine adapted slowly. Panthers began engaging at even longer ranges, 1,500 to 2,000 yards, where their guns retained effectiveness, but American HVAP accuracy degraded. They used terrain more carefully, positioning only turrets above cover to minimize target exposure. They concentrated multiple Panthers in mutual support, reasoning that even if American tanks could kill one Panther frontally, they couldn't kill 3 simultaneously. But these adaptations came too late and were undermined by strategic collapse. By early 1945, German armored forces lacked fuel for repositioning, lacked replacements for lost tanks, and lacked air cover for daylight operations. Tactical adjustments could not compensate for systemic failure. HVAP did not win the war, but it removed the final German tactical advantage at precisely the moment when Germany could least afford to lose it. American commanders recognized HVAP's strategic value beyond immediate battlefield effects. Crew confidence improved dramatically. Tank units that had suffered from morale problems, refusal to advance, psychological casualties, high desertion rates, stabilized. Men who believed they could fight effectively were willing to fight. Men who expected to die were not. This morale effect rippled through entire divisions. Armored advances that had previously required overwhelming force concentration could now be conducted with smaller spearheads. Casualty rates declined, operational tempo increased. The psychological burden of facing German heavy armor, a burden that had weighed on American tank crews since Normandy, lifted. The tactical doctrine shift HVAP enabled was not revolutionary. It did not invent new maneuver concepts or redefine armored warfare. It simply allowed American crews to fight the way their doctrine had always intended, with aggressive forward movement, acceptance of frontal engagements, and confidence that their weapons could destroy their enemies. For 18 months, inadequate ammunition had forced them to fight defensively, despite offensive doctrine. HVAP restored alignment between doctrine and capability. The result was an American armored force that finally matched its own self-image. Mobile, aggressive, and lethal. January 8, 1945. Outside Bastogne, Belgium. Temperature, 12 degrees Fahrenheit. The snow had stopped falling 2 hours before dawn, leaving the landscape frozen and silent under a sky beginning to pale toward gray. Sergeant Bill Harper's Sherman sat hull down behind a destroyed farmhouse, engine idling to keep the crew from freezing. They'd been in position since 0400 hours, waiting for German armor reported moving south along the Houffalize Road. Harper had 11 HVAP rounds, more than most crews. His company commander had scrounged them from division supply during the chaos of the Bulge's opening week, when normal accountability procedures collapsed under emergency conditions. Harper treated them like diamonds, logged, inventoried, checked twice daily to ensure none had been pilfered by desperate crews from other platoons, through his periscope movement. 600 yards out, emerging from tree shadows along the road, a Panther Ausf. G, its long gun traversing slowly as it advanced. Then another Panther. Then a third. A platoon, moving in tactical formation with 50-yard intervals, hunting for the American infantry holding Bastogne's perimeter. Harper's radio crackled, his platoon leader's voice, tense but controlled. All Cobra elements, Panthers at grid 847-293. Engage at your discretion. Use special ammunition, special ammunition. The euphemism they'd adopted for HVAP to avoid mentioning it over potentially compromised radio channels. Harper's gunner, Corporal Eddie Vance, was already tracking the lead Panther through his telescopic sight. Range 600, moving left to right. 10 miles per hour. The loader, Patterson, pulled an HVAP round from the ready rack. The black tip seemed darker in the pre-dawn gloom. He slid it into the breech with the careful precision of a man handling something irreplaceable. HVAP up. Harper made his decision. They had clear shots at all three Panthers, still beyond the range where standard ammunition offered reliable kills, but well within HVAP's effective envelope. The tactical situation was perfect. Hull-down position, surprise, first shot advantage. If they didn't use HVAP now, when would they? Gunner, target Panther front. Aim center mass on the glacis. Vance's breathing steadied. He'd done this calculation 100 times in his head over the past month. The moment when he'd finally fire the ammunition that was supposed to change everything. His hand hovered over the trigger, waiting for the Panther to move into the precise angle where the glacis plate presented its full frontal profile. The Panther obliged. It pivoted slightly, exposing its hull as it maneuvered around a crater. Vance tracked the movement with minute adjustments of the traverse wheel. The crosshairs settled on the glacis, just left of center. The range was closing, 580 yards now. Better. On the way. The gun fired. The recoil was no different than standard ammunition, but somehow Vance felt like the shot carried different weight. The 3-second flight time stretched into eternity. The HVAP round struck the Panther's glacis plate 2 feet below the driver's hatch. There was no ricochet spark, no deflection. The tungsten core punched through 80 millimeters of sloped armor like a drill through wood. The entry hole perfectly circular and barely visible from 600 yards. For one heartbeat, nothing happened. The Panther continued rolling forward as if untouched. Then smoke erupted from every hatch simultaneously. Not the black smoke of burning fuel, but the gray-white smoke of internal fires. Ammunition cooking off, hydraulic fluid burning, upholstery igniting. The Panther's turret hatches blew open and crew members bailed out, one of them on fire, rolling in the snow to extinguish flames. The tank lurched to a stop, smoke pouring from the engine deck. Harper's radio exploded with chatter. Every American tank that had witnessed the kill was transmitting at once, voices overlapping in excitement and disbelief. The second Panther stopped abruptly, its commander clearly confused about what had just destroyed his platoon leader. The third Panther began reversing, seeking cover. Gunner, target second Panther. Vance was already on it. The stationary target made calculation simple. Identified. Fire. The second HVAP round crossed the distance in 2.8 seconds and struck the Panther low on the glacis, near the junction with the hull floor. The penetration was clean, but the post-penetration effect was catastrophic. The tungsten core tumbled through the fighting compartment and struck stored ammunition. The Panther exploded, not a fire, but a detonation that blew the 45-ton vehicle apart. The turret separated from the hull and landed 15 feet away. Fragments of armor plate spun through the air like leaves. The third Panther abandoned its retreat and accelerated forward, attempting to close range where its own gun could retaliate. Its turret traversed toward Harper's position, the 75mm gun elevating. The German commander had identified the threat and was reacting with the trained aggression that made Panther crews so dangerous. But he was still 600 yards out, and Harper had 9 HVAP rounds left. Gunner, Panther, front charging. Fire when ready. Vance tracked the moving target, leading it slightly to account for lateral movement. The Panther was accelerating, 20 miles per hour now, closing the distance rapidly. In 30 seconds, it would be within lethal range. Vance exhaled slowly, let his body settle into the gun mount, and squeezed the trigger on the upswing of the Sherman's suspension bounce. The HVAP round took the Panther through the right side of the glacis, penetrating at an oblique angle. The effect was less dramatic than the previous two hits. No immediate fire, no explosion. But the Panther veered sharply left, its driver killed instantly, and crashed into a drainage ditch where it came to rest at a 30-degree angle. Smoke began seeping from the engine compartment. After 20 seconds, the remaining crew bailed out and ran for the tree line. 3 Panthers dead in 90 seconds. 0 American losses. The engagement lasted less time than it took to describe it. Harper sat back in his commander's seat, heart hammering. Around him, the crew was silent. Not from fear, but from the realization that they'd just experienced something unprecedented. For 18 months, facing a Panther had meant death or retreat. Now it meant victory. The radio chatter continued. Other tanks in the platoon were reporting Panther kills with HVAP. Lieutenant Morrison's tank claimed 2 at 700 yards. Sergeant Collins knocked out a Panther that had been hull down behind a hedgerow, the HVAP round punching through both the earthen berm and the tank's armor. Across the Bastogne perimeter, American crews were learning the same lesson Harper had just learned. HVAP worked exactly as promised, but the Germans were learning too. Over the next 72 hours, Panther tactics changed noticeably. German armor began engaging from extreme range, 1,800 to 2,000 yards, where HVAP accuracy degraded and Panther guns retained effectiveness. They used reverse slope positions more extensively, exposing only their turrets. They concentrated their remaining armor in smaller, more defensible sectors rather than spreading across the front. Most significantly, they stopped advancing aggressively. The armored counterattacks that had characterized German defensive doctrine gave way to static, hull-down defensive fighting. American intelligence officers noticed the shift immediately. Interrogated German tank commanders described receiving orders to avoid frontal engagements with Sherman tanks at medium range, orders that would have been unthinkable a month earlier. One captured Panzer lieutenant told his interrogators, "We were told the Americans have new ammunition. Very dangerous. We must not let them get close shots." The psychological reversal was complete. For the first time in the European campaign, German armor feared American tanks. The climactic engagements of early January 1945 were not single dramatic battles, but rather dozens of small, violent encounters across the Belgian and German frontiers, where HVAP-equipped Shermans systematically destroyed Panthers that German doctrine had positioned to stop American advances. At Houffalize, at St. Vith, at Viel-Salm, at countless unnamed crossroads and villages, American tank crews fought with newfound confidence and killed German armor at ranges they'd never imagined possible. The statistics told the story. In December 1944, before widespread HVAP distribution, American tank versus Panther exchange rates averaged 3.6 Shermans lost for every Panther destroyed. By late January 1945, with HVAP widely available, the ratio had reversed. 1.2 Panthers lost for every Sherman. The difference was not just numerical, it was psychological, operational, and strategic. The transformation of American armored capability reached its apex during the final push into Germany in February and March 1945. By this point, HVAP production had reached 120,000 rounds per month. Distribution improved dramatically. Most 76mm Sherman crews now received 15 to 20 HVAP rounds as standard allocation. The ammunition was no longer precious. It was standard loadout. Tank commanders stopped hoarding it and started employing it as their primary anti-armor round, relegating standard M62 ammunition to secondary targets. The operational effects were immediate and profound. On February 23, 1945, elements of the 3rd Armored Division approached the Roer River crossing at Ardennes. German forces had established a defensive line anchored by 12 Panthers positioned in rubble and ruins, their guns controlling the approaches to the bridge. Previous American doctrine would have called for extensive artillery preparation, airstrikes, and a deliberate flanking maneuver consuming days and accepting heavy casualties. Instead, Lieutenant Colonel William Lovelady's task force attacked directly. His lead company, 18 Shermans, each carrying 20 HVAP rounds, advanced in line formation across open ground at dawn. The Panthers opened fire at 1,400 yards, destroying 2 Shermans in the opening salvo. American tanks did not retreat. They did not maneuver. They stopped, hull down in shallow folds in the terrain, and returned fire with HVAP. The engagement lasted 11 minutes. When it ended, 10 Panthers were burning or abandoned. The remaining 2 withdrew across the bridge, which German engineers then demolished. American losses: 4 Shermans destroyed, 2 damaged. The exchange rate, 2.5 Panthers per Sherman, would have been unthinkable 6 months earlier. But more significant than the numbers was the operational tempo. Lovelady's task force crossed the Roer using a hastily constructed pontoon bridge and continued advancing that same afternoon. There was no pause to reorganize, no delay to bring forward reinforcements. The Panthers, once an obstacle requiring days to overcome, had become merely another tactical problem solved in minutes. German commanders recognized the shift, but lacked resources to counter it. General Hasso von Manteuffel, commanding 5th Panzer Army, wrote in his after-action report, "American tank guns have improved dramatically. Our Panthers no longer possess immunity at combat ranges. Frontal engagements must be avoided, but terrain and fuel shortages make maneuver impossible. We are forced to fight defensively in conditions where defense no longer offers advantage." This admission, buried in Wehrmacht archives and only discovered after the war, represented the final collapse of German armored doctrine. The Panther had been designed as a defensive weapon, leveraging superior armor and firepower to stop numerically superior enemies. When that defensive advantage evaporated, the Panther became merely a target. The psychological effects on German crews were documented extensively in post-war interrogations. Hauptmann Erich Barkmann, a veteran Panther commander with over 80 tank kills, described his final engagement on March 7, 1945, near Remagen. "We engaged 3 American Shermans at 700 meters. I was confident. This was ideal range for us. My gunner fired first and hit the lead Sherman in the hull. It did not stop. It fired back. The round struck my glacis and penetrated completely. I could not believe it. The glacis had never been penetrated before. We bailed out immediately. When I looked back, there was a small hole in the armor. Very clean, very precise. I knew then that something had changed fundamentally." Barkmann survived the war. Many of his fellow Panzer commanders did not. The casualty rates among German armored forces in early 1945 reflected not just numerical inferiority, but also the collapse of tactical advantages they had relied upon since 1943. American crews, meanwhile, experienced the opposite transformation. Staff Sergeant James Bates, who had survived Normandy, the Bulge, and the drive into Germany, described the psychological shift in a letter home dated March 15, 1945. "We don't run from Panthers anymore. We hunt them. The boys actually get excited when we spot one because we know we can kill it now. It's like going from being the rabbit to being the wolf. That new ammunition, I can't tell you exactly what it is. Sensors won't allow it. But it's made us into a real army instead of just a bunch of guys hoping not to die." The climactic moment came not in a single battle, but in the cumulative effect of hundreds of small victories. Each Panther destroyed with HVAP reinforced crew confidence. Each engagement won at ranges previously dominated by German guns validated American industrial innovation. Each day that passed with improving exchange rates demonstrated that material superiority, properly applied, could overcome tactical disadvantage. The Battle of Remagen illustrated this transformation perfectly. On March 7th, when American forces unexpectedly captured the Ludendorff Bridge intact, German high command rushed armored reserves to contain the bridgehead. Among them were elements of the 9th Panzer Division, including 32 operational Panthers. Their mission: destroy the bridge or annihilate American forces on the east bank of the Rhine. American forces defending the bridgehead included portions of the 9th Armored Division, approximately 60 Shermans, most mounting 76mm guns with full HVAP allocations. The terrain favored defense, open approaches, clear fields of fire, and the Rhine at their backs, preventing retreat. The German attack commenced at dawn on March 8th. Panthers advanced in company strength, attempting to overwhelm American positions through aggressive maneuver and firepower. American doctrine 6 months earlier would have been defensive. Hold positions, call for air support, accept losses while buying time. Instead, American tanks counterattacked. They advanced from their defensive positions and engaged the Panthers at ranges between 600 and 800 yards, the optimal envelope for HVAP effectiveness. The engagement became a meeting battle, with both sides maneuvering aggressively and trading fire at medium range. When the battle ended 4 hours later, 19 Panthers had been destroyed or abandoned. American losses totaled 14 Shermans. The exchange rate, 1.35 to 1 in favor of the attackers, represented a complete reversal of historical patterns. More significantly, the German attack had failed entirely. The bridgehead held. The Rhine was crossed. The gateway to Germany's industrial heartland stood open. Wehrmacht commanders attempting to analyze the defeat struggled to reconcile battlefield reports with their understanding of armored warfare. Panthers should not lose to Shermans in open combat. The Panthers' technical specifications, superior gun, superior armor, superior optics, had not changed. Yet Panthers were dying in numbers that made no tactical sense. The answer lay in those black-tipped rounds that German ordnance officers had only recently identified. By March 1945, Wehrmacht intelligence finally understood what they faced, but understanding came too late. Germany lacked the tungsten to produce equivalent ammunition. German factories lacked the production capacity to manufacture new weapons. German armies lacked the fuel to maneuver their remaining Panthers away from unfavorable engagements. The strategic window for response had closed before Germany even knew the window existed. American armored divisions exploited their advantage ruthlessly. They advanced with confidence, accepted combat at ranges they'd previously avoided, and destroyed German armor with an efficiency that shocked even their own commanders. General Maurice Rose, commanding the 3rd Armored Division, noted in his March 20th diary entry, "The men are fighting like they know they're going to win. That's worth more than any weapon." Rose would die 5 days later, shot by a German tank commander during a confused close-range encounter. But his observation captured the essential truth. HVAP had not just improved American tanks, it had transformed American tankers from cautious survivors into aggressive hunters. The climax of the HVAP story was not a single dramatic moment, but rather the cumulative transformation of an entire army's fighting capability. From January through March 1945, American armored forces evolved from tactical inferiority to tactical parity to tactical superiority. The Germans noticed, so did the Americans, and in the cold, practical calculus of armored warfare, superiority meant survival. Inferiority meant death. The black-tipped rounds had rewritten those equations entirely. By the time Germany surrendered in May 1945, American factories had produced over 800,000 M93 HVAP rounds. Most were never fired. The need for them diminished as German armored resistance collapsed under the weight of strategic defeat. But their existence, their availability, their proven effectiveness shaped the final months of combat in ways that transcended simple battlefield outcomes. they changed what men believed possible. And in war, belief determines action, and action determines victory. May 8, 1945. Through the years, war in Europe ended not with a climactic final battle, but with signatures on surrender documents and the gradual silence of guns that had fired continuously for 6 years. When the shooting stopped, American ordnance officers began the tedious process of accounting for materials scattered across a continent. Among the thousands of items inventoried were HVAP rounds, some still loaded in tanks, others stored in ammunition dumps, many expended in combat that would never be fully documented. The final production numbers told part of the story. Between October 1944 and May 1945, American industry manufactured 847,000 M93 HVAP rounds for the 76mm gun. Of these, approximately 320,000 were shipped to Europe. Combat expenditure records, incomplete due to wartime chaos, suggested that roughly 180,000 rounds were actually fired in combat. The remainder sat in supply depots, aboard ships still crossing the Atlantic, or in factory warehouses when production ceased. The statistical impact on tank versus tank engagements proved difficult to quantify with precision. American after-action reports often failed to distinguish between kills achieved with HVAP versus standard ammunition. Tank crews in the chaos of combat could not always identify which round type they'd loaded when firing at multiple targets in rapid succession. German loss records, scattered and incomplete as their armies collapsed, rarely specified the ammunition type that destroyed each vehicle, but patterns emerged from the fragmentary data. Analysis by U.S. Army Ordnance. Department historians in 1946 examined 847 documented engagements between 76mm Shermans and Panthers from January through April 1945. They found that in engagements, where HVAP was confirmed as available and employed, American losses averaged 1.4 Shermans per Panther destroyed, compared to 3.2 Shermans per Panther in engagements using only standard ammunition. The difference represented hundreds of American lives saved and dozens of successful operations that might otherwise have failed. More revealing were the German assessments. A post-war interrogation of General der Panzertruppe Fritz Bayerlein, who commanded Panzer Division through the final campaigns, included his observation. By February 1945, our tank commanders reported that American Shermans were defeating Panthers in frontal engagements at ranges we believed impossible. At first we thought this was exaggeration or poor tactics on our part. Then we examined knocked-out Panthers and found small, clean penetration holes through the glacis plate. Our metallurgists identified tungsten. We realized the Americans had developed ammunition we could not counter. Morale among panzer crews deteriorated rapidly after this. Men who had believed their armor made them invulnerable now knew they could die as easily as the Americans they had been killing. This psychological dimension, harder to quantify than armor penetration or exchange rates, shaped the final months of combat in ways that tactical analyses often overlooked. German armored forces that had fought aggressively throughout 1944 became cautious and defensive in 1945. Panthers that had previously advanced to engage. American positions now waited in static defenses, preserving fuel and ammunition for survival rather than victory. The offensive spirit that had characterized German armored doctrine since 1940 evaporated under the twin pressures of material shortage and the realization that technological superiority had vanished. American crews experienced the opposite transformation. Letters and diaries from the period document a shift from fatalistic resignation to aggressive confidence. Corporal Robert Welch, a loader with the 4th Armored Division, wrote to his family in April 1945, "We're not afraid of the big German tanks anymore. We've got ammunition now that can knock them out clean." The guys actually volunteer for point duty because they know if we see a panther, we can kill it before it kills us. That's a hell of a change from last year when nobody wanted to be anywhere near the front when German tanks showed up. The casualty statistics reflected this shift. In the 3rd Armored Division, one of the most heavily engaged American armored formations, tank crew casualties declined 43% between the last quarter of 1944 and the first quarter of 1945, despite increased operational tempo and deeper penetration into German territory. Similar patterns appeared across other armored divisions. Men were fighting more but dying less, precisely because they possessed weapons that allowed them to fight effectively rather than simply absorb punishment. Yet HVAP's impact remained constrained by scarcity. Even at peak production in early 1945, supply never met demand. Tank crews rationed their HVAP rounds carefully, saving them for engagements against heavy armor while using standard ammunition against softer targets. This conservation mindset, ingrained during months of severe shortage, persisted even when supply improved. Some crews finished the war with HVAP rounds still in their racks, having been too cautious to expend them. The scarcity also created disparities between units. Divisions with effective supply networks and aggressive logistical officers received generous HVAP allocations. Divisions with less efficient supply chains or lower priority received minimal quantities. A Sherman crew in the 2nd Armored Division might have 30 HVAP rounds in March 1945, while a crew in the 9th Armored Division had only 8. Both crews faced identical tactical challenges, but one possessed 3 times the capability to address them. This inequality generated resentment that persisted into post-war veteran accounts. Tank crews who fought without adequate HVAP felt abandoned by a supply system that distributed life-saving ammunition unevenly. Those who received generous allocations often felt guilty that their survival came partly from bureaucratic fortune rather than purely from skill or courage. German tactical adaptation to HVAP appeared in captured documents and post-war interrogations. Wehrmacht training bulletins from February 1945 instructed Panther crews to engage American armor only at ranges exceeding 1,000 meters, to use terrain aggressively to minimize frontal exposure, and to disengage immediately if engaged by what the documents called enhanced American anti-tank weapons. These instructions represented a complete reversal of doctrine that had previously emphasized aggressive forward defense and acceptance of frontal duels, but adaptation required resources Germany no longer possessed. Disengaging from unfavorable combat required fuel for mobility, fuel that barely existed in Wehrmacht supply chains by early 1945. Positioning. Tanks in favorable terrain required reconnaissance and planning, time that collapsing defensive lines did not allow. The tactical adjustments that might have mitigated HVAP's effectiveness were impossible to implement under conditions of strategic collapse. Some German units attempted technological countermeasures. Reports from March 1945 described Panthers fitted with additional frontal armor, spare track links, concrete, sandbags, in desperate attempts to increase protection. These field modifications added weight without adding meaningful protection. The tungsten cores punched through improvised armor as easily as they penetrated steel plate. The modifications succeeded only in reducing mobility and increasing mechanical failures. The long-term consequences of HVAP extended far beyond the immediate tactical victories of 1945 when Allied intelligence teams entered Germany after the surrender. They gained access to Wehrmacht armored warfare research facilities, testing grounds, and design bureaus. Among the documents recovered were German assessments of American HVAP ammunition, compiled in the final months of the war when German engineers finally obtained samples for analysis. The Kummersdorf Proving Ground Report, dated April 3, 1945, was particularly revealing. German ballisticians had test-fired captured HVAP rounds against representative Panther armor sections at various ranges and angles. Their findings confirmed what battlefield results had already demonstrated. The M93 round could reliably penetrate Panther frontal armor at ranges up to 1,200 meters under ideal conditions. The report concluded with a frank admission. American tungsten core ammunition represents a qualitative leap we cannot match with current production capabilities. No practical armor thickness can defeat this projectile type without unacceptable weight penalties. Future tank design must assume projectiles of this nature as standard threat. This conclusion, that kinetic energy penetrators made traditional armor obsolete, would dominate Cold War tank development. The Germans had reached this understanding too late. The Americans and Soviets would build their post-war armored forces around it. Soviet intelligence obtained HVAP samples through multiple channels. Red Army forces captured American ammunition during the confusion of Allied-Soviet link-ups in April 1945. Soviet intelligence officers in the United States acquired technical specifications through espionage networks. By 1946, Soviet ordnance engineers were developing their own tungsten core ammunition. Though Soviet designations and manufacturing techniques differed from American approaches, the British, who had developed their own APDS, armor-piercing discarding sabot, ammunition in parallel with American HVAP, compared notes with U.S. ordnance teams after the war. British APDS used a 3-petal sabot design versus the American 4-petal design, and British tungsten cores were slightly smaller diameter. Testing revealed similar performance characteristics. Both ammunition types achieved penetration impossible with conventional steel projectiles. The convergent development validated the fundamental physics. Hard, dense, small-diameter projectiles at extreme velocity represented the future of anti-armor warfare. American post-war analysis examined whether HVAP had influenced the war's outcome in measurable ways. The conclusion was nuanced. HVAP had not won the war. Germany's strategic defeat resulted from overwhelming Allied material superiority. Soviet advances in the East, collapse of German industry under bombing, and fundamental errors in Nazi political and military leadership. But HVAP had accelerated victory and reduced American casualties during the final campaigns. Estimates suggested that without HVAP, American armored operations in early 1945 would have proceeded more slowly, suffered higher losses, and required greater concentration of forces to overcome German defensive positions. The delay might have been measured in weeks rather than months, but those weeks represented thousands of casualties avoided and significant operational advantages secured. Sherman crews who survived the war because HVAP allowed them to kill Panthers that would otherwise have killed them rarely contemplated these abstractions. They knew only that the black-tipped rounds had saved their lives. The ammunition's scarcity throughout its service life prompted post-war debates about tungsten allocation priorities. Some analysts argued that HVAP should have received higher priority earlier, that diverting tungsten from industrial applications to ammunition production in mid-1943 might have prevented the crisis of confidence among tank crews in Normandy. Others countered that tungsten shortages were real and that machine tools required tungsten as urgently as ammunition did. The debate remained unresolved, though most participants acknowledged that American industrial planning had responded as quickly as practical constraints allowed. Tungsten supply chains became a focus of early Cold War strategic planning. The United States and Soviet Union both recognized that future armored conflicts would consume tungsten core ammunition at rates that could exhaust national stockpiles in months of intensive combat. Both nations established tungsten reserves, secured long-term contracts with mining operations in neutral countries, and developed recycling programs to recover tungsten from expended ammunition and worn machine tools. The M93 HVAP round remained in U.S. Army inventory through the early 1950s, though its relevance declined as new tank guns and ammunition types entered service. The 90mm gun, equipped on M26 Pershing tanks and later M46 and M47 Pattons, offered superior performance with conventional ammunition, reducing dependence on tungsten core rounds. By the Korean War, HVAP for the 76mm gun was considered obsolete, though some stocks were expended in training or against North Korean T-34-85 tanks in the war's opening months. Veterans who had fought with HVAP maintained strong opinions about its significance throughout their lives. Reunion associations for armored divisions often featured discussions about the black-tip rounds and their impact on combat operations. Some veterans credited HVAP with their survival, citing specific engagements where HVAP penetrations killed enemy tanks that would otherwise have destroyed them. Others dismissed HVAP as overrated, arguing that superior numbers, air support, and German fuel shortages mattered more than ammunition types. The historical record supports elements of both perspectives. HVAP was tactically significant. It demonstrably improved American armor's effectiveness against German heavy tanks. But it was not strategically decisive. Germany would have lost the war regardless of HVAP's existence. The ammunition's true importance lay in the human dimension. It restored confidence to crews who had lost it, enabled aggressive operations by forces that had fought defensively, and reduced casualties among men whose survival mattered to families, communities, and the nation they served. German veterans viewed HVAP differently. For them, it represented the moment when their final technical advantage vanished. Panzer commanders who had entered the war believing in German engineering superiority watched that superiority erode gradually, first through Soviet T-34s, then through overwhelming Allied numbers, finally through American ammunition that negated the Panther's protective advantage. HVAP symbolized the totality of Germany's defeat, not just military collapse, but technological irrelevance. Post-war armor development proceeded along trajectories HVAP had illuminated. The race between projectile and armor continued, but the terms had changed. Instead of thicker armor, designers pursued composite armor, reactive armor, and sloped configurations that might defeat kinetic penetrators. Instead of larger guns, designers pursued higher velocities, better penetrator materials, and fin-stabilized projectiles. The M93 HVAP round was primitive by later standards. Crude manufacturing, limited range, inconsistent quality control. But it established principles that defined armored warfare for decades. The 76mm Sherman gun that fired HVAP became obsolete within years of the war's end. The Sherman tank itself transitioned from frontline service to secondary roles, then to surplus sales and museum displays. But the black-tipped rounds that had briefly made Shermans competitive against Panthers represented something more enduring, proof that material science and industrial capacity could overcome battlefield inferiority faster than new weapons platforms could be designed. This lesson that incremental improvements to existing systems often deliver results faster and cheaper than revolutionary new systems, influenced American military procurement philosophy throughout the Cold War. It validated an approach that prioritized practical solutions over perfect designs, adequate performance over maximum performance, and rapid fielding over extended development. The men who loaded those black-tipped rounds into their guns in the winter of 1944-45 did not think in terms of procurement, philosophy, or long-term strategic impact. They thought about survival, about killing enemy tanks before those tanks killed them, about finishing the war and going home. For them, HVAP was not a case study in industrial innovation or a milestone in ammunition development. It was the difference between fear and confidence, between helplessness and agency, between dying in Belgium and surviving to see peace. That difference, measured not in armor penetration, statistics, or exchange ratios, but in human lives, preserved, was the aftermath that mattered most. The story of HVAP is not really about ammunition at all. It is about the moment when industrial power translated into battlefield power, when American factories, working with scarce materials and urgent deadlines, produced a solution that changed the calculus of armored warfare in the war's final months. It is about men who carried those black-tipped rounds into combat, not knowing if the promises made by engineers thousands of miles away would hold true when steel met steel. At 600 yards, the tungsten cores that punched through Panther armor represented more than metallurgy. They represented a nation's ability to identify a problem, mobilize resources, and deliver solutions fast enough to matter. The Germans had built better tanks. The Americans built better ammunition. And in the narrow window between January and May 1945, that distinction decided who lived and who died in hundreds of small, brutal engagements that history would barely remember. What the Germans never expected was not simply that HVAP would work. It was that the Americans would develop it at all. German armor doctrine assumed Allied tanks would remain inferior. That numerical superiority and air power would compensate for technical disadvantage. That the war would be decided by grand strategy rather than small innovations. They were wrong. The war was decided by grand strategy, but small innovations determined how many men survived to see victory. For the crews who loaded those rounds, fired them, and watched Panthers burn at ranges they had thought impossible, HVAP represented something simpler and more profound. Hope. Hope that ingenuity could overcome intimidation. Hope that the men designing weapons in distant proving grounds understood what soldiers needed. Hope that tomorrow's engagement might be survivable when yesterday's had seemed suicidal. The black-tipped rounds fired in the winter forests of Belgium, and the spring offensives into Germany are long since expended. The tungsten cores that penetrated so many Panthers have been lost to history, buried in scrap yards or museum storage, or the earth of battlefields now returned to farmland. The men who loaded them are nearly all gone now, their stories fading into archives and memorial plaques. But the principle they proved endures, that wars are won not just by courage or strategy, but by the unglamorous work of engineers and factory workers and supply sergeants who turn raw materials into advantages measured in millimeters of penetration and seconds of reaction time. The Germans never expected HVAP rounds to make 76mm Shermans into Panther-killers because they never imagined their enemies could close the technical gap so quickly. They learned otherwise, one black-tipped round at a time. The men who fought with HVAP rarely spoke about the ammunition itself in later years. They spoke about the battles, the friends they lost, the moments that defined their service. But when they did mention those black-tipped rounds, in letters, in memoirs, in quiet conversations at reunions, they spoke with a reverence reserved for things that saved lives. The 77mm Sherman would be remembered as adequate. The Panther would be remembered as formidable. But HVAP, the ammunition that transformed one into a threat to the other, would be remembered by those who needed it most as the round that gave them a fighting chance. And in war, a fighting chance is sometimes all the difference between history and tragedy. If this story revealed a side of World War II tank combat you'd never heard before, hit that like button and subscribe for more untold stories from history's most decisive battles. We uncover the weapons, tactics, and innovations that changed the course of warfare, one detail at a time. What other overlooked technologies from WW should we explore next? Drop your suggestions in the comments below, and if you want to dive deeper into American armor doctrine, see the Sherman's evolution, or the Panther's design philosophy, check out the videos linked in the description. Thanks for watching. History is written by the victors, but it's remembered by those who understand the details that made victory possible.